In part 2 of ellipses, we're going to do examples of ones that are centered at the origin and ones that are centered off of the origin as well. But let's start with ones that are centered at the origin. If we know that it's centered at the origin and we're told that it's an ellipse and we're told that the vertex, one of the vertices is -6, 0 and one of the co-vertices is 0, 3, we can write the equation of the ellipse off of that information. We can also draw it. We can also tell where the foci are. We can tell a lot. We can the length of the major axis, the length of the minor axis. There's a lot of information we can get from just being given this limited information. So let's go into the example. I always suggest in conic sections to sketch what you know. When you visualize it in a picture, it makes it so much easier. I don't want you to memorize a formula or memorize a bunch of letters and how the letters work together. I want you to always be able to visualize it, and then it makes it so much easier to remember. So what you're going to do is you're going to draw an x and a y axis, and let's think about where these points are. So -6, 0 would be somewhere over here, so this would be a vertex. So if the center is at the origin, you can already know that the other vertex is going to be over here, and it's going to be at 6, 0. Then, same with the co-vertices. If you know that one co-vertex is at 0, 3, it'll be up about halfway as much as the other one. And so this would be your co-vertex. So your other co-vertex will be down here 3 units in the other direction. So the other co-vertex would be 0, -3. And this one would be the 0, 3. So we can already draw the ellipse and get a really good feel for what it looks like. So there's our ellipse, and we also know where the foci have to be. The foci have to be inside the vertex somewhere, inside the curve, close to the vertex, and so these are going to be our foci. Now we can figure out where those are based on the information from the vertices and the co-vertices. What's good to find is what is A, what is B, and what is C. Those are going to be very important to finding everything else. And so remember, A is the distance between the center and the vertex. It's on the major axis, and it's this distance right here. And we can tell from the picture the distance between the center and the vertex would be 6 units. In either direction that you want to go from the center to the vertex, you're talking about 6 units. Then the distance between the center and the co-vertex represents B all the time, and that is a distance of 3, no matter which way you go. Then C, remember, comes from a formula, and it's the C squared equals A squared minus B squared. That's always the formula for ellipses to help you find C. And so if we fill in the values for A and B, we have 6 squared minus 3 squared, which gives us C squared equals 27. So if you want to find C, you would square root 27, which would be the square root of 27, which actually, if you know my prism break method, or just simplifying radicals, that would be actually 3 square root of 3. That's how you would write C if you needed to write it. So if we were to write the location of the focus, we know that it is 3 square root of 3, comma 0. That's where that focus is located. So the other focus would be located at -3 square root of 3, comma 0. Now you may or may not be asked for all that information, but it is good to sketch a drawing just to kind of get a feel for where everything is. Then what the question may be asking for is the equation of the ellipse that has these properties. And if that's the case, you can see I've written the formula that would go with this, the equation that would go with this particular ellipse. And then the reason I wrote it this way was because the A squared has to be under the X, not the Y, since the ellipse is longer in the X direction, along the X-axis or in the direction of the X-axis. And so therefore, if we think about it, we've got our center at 0, 0. So our h and k end up just going away because they're zeros. And so you end up with x squared over, and then a was 6, so a squared is 36. That's what you write underneath there. And then y squared is what you write on top. And then the bottom would be b squared, which is 3 squared, which is 9. And then it's always equal to 1. So the c doesn't show up anywhere in the formula, but the a and the b do. So if you didn't need to find c right here, you could live without that if they never asked anything about the focus. But a lot of times they want to know what where the foci are, and they'll ask you that question, so it's always good to know how to find it. So this equation is the equation that goes with that ellipse. In our second example, we're going to graph the ellipse and specifically find the foci, and we are given the equation and not any features, and so we need to go from the equation over to the features and the graph. And so in this particular example, you'll notice one thing right off the bat. This is very similar to a circle equation. A circle equation, the only difference you'll notice with a circle equation is that the numbers in front of the x and the y will always be the same. In an ellipse, they'll be different because it's lopsided. But this will end up, when we get to circles, you'll see that this is very similar to the circle equation. X squared plus y squared equals the radius squared is what the circle will look like. But this one has uneven values in front of the x and y. And what's going to happen is this doesn't look like the ellipse form that we had on the previous page. And so what we need over here on the end is a 1. We always have to have a 1 there for it to be in the form that we need it in so we can find our a, b, and c. And so what we're going to do is we're going to divide by whatever number is over there, and that will give us a 1. But if you divide it there, you've got to divide it on the other side, and I'm going to do it to each one individually. And then you want to go through and reduce each fraction. Usually they'll give you something that goes in evenly to where it'll be nice fractions. So let's do that. So 25 over 225, if you reduce that, it is 1/9. And so I dropped the 1 that would be in front of the x squared and just called it x squared over 9. And also 9 over 225 happens to be 1 over 25 when you reduce it. And I dropped the 1 there as well. So now it looks like the format that we're used to, and now we know what our a and our b are, and therefore we'll be able to find our c. Our a is, remember this is a squared and b squared, except you've got to watch which one's bigger. So actually this one is your a squared and this one is your b squared, because a always has to be bigger. So that immediately tells you, since the bigger number is under the y squared, that this is going to be a vertical ellipse. Then what we want to do is always square root those numbers when we put them down as a and b, because a is actually 5 and b is actually 3. And then c is always found with the formula c squared equals a squared minus b squared. And it's always a squared minus b squared because a squared will always be bigger. And then you can even look at the a squared and b squared spots, which are 25 and 9, or you can just square your a and b if you didn't have that. And we get c squared equals 16. Well, that one turns out nice because when we square root that to find c, we get 4. So if we graphed that on a grid, what you could do is you could put some points down first. So you know that the center is at 0, 0 because there wasn't an h and a k, so they must have been 0, 0. And then from there to the vertex has to be the a amount, which is 5 units. So you go 5 units in each direction and put a dot there. So if you were graphing it yourself, you'd go 5 units up and 5 units down. Then we also know that our b value is 3, so that's the distance between the center and one of the co-vertices. And so we would go 3 units to the left and 3 units to the right, and we would get our co-vertices. Then you'd be able to draw the ellipse, and then the added piece that we don't have here that isn't required to draw the ellipse is the foci, and if they want you to find the foci, which they usually do, you go ahead and put those in at the distance of C. So C was a distance of 4, so you would go 4 units up and 4 units down, and that would be where your foci would be located. Other features that they sometimes will ask for is the length of the major axis. Sorry, that's supposed to be an MAJ. The length of the major axis and the length of the minor axis. And again, you just can almost count, just based on the information you have. The length of the major axis was a 5 plus another 5, or 2 times 5, which is 10. And the length of the minor axis is 2 times the distance 3, so that would be a 6. The last video that we're going to do about ellipses is now going to be translating them off of the origin, or moving them away from the origin, and where we will have an H and a K that are different than 0, 0. So that's the end of this video.